we'll now list down the organic compounds that contains nitrogen. We start off with actually all your amines. You can see all the amines are here. And one of the things to highlight for amine is that tertiary amine lacks electron deficient hydrogen, unlike the case of your secondary and your primary amines, where the hydrogen directly bonds to the nitrogen. The next one is your quaternary ammonium salt. It was actually introduced in the topic in halogenoalkane. And when ammonia or amine reacts with halogenoalkane, and you remember the reactions when halogenoalkane is in excess, and the reaction does cascade, and you will end up with a quaternary ammonium salt. We also did highlight to say that quaternary ammonium salt is an ionic compound, and therefore crystalline in structure and highly soluble. Aromatic amine we have for this compound is your phenylamine. Pretty similar to phenol. There's some unique reactions, and later we will take a look at that. Next one is actually your amide. Amide, you can have 1 degree, 2 degree, or 3 degree. 3 degree amide means that there's no hydrogen bonded to the end, while 2 degree amide means there's only 1 hydrogen, while in the case of primary amide, you will get 2. We have your nitrile. That's something that we talked about when we were dealing with the topic ketone and aldehyde, where HCN reacts with your ketone and aldehyde to produce your hydroxynitrile. We did highlight that the nitrile is highly reactive as a group. Imide looks a bit like amide, but you actually have if on a closer look, it looks as if that you have 2 amide. As if that you have 2 amide functional group joined together by a common nitrogen. The last but not least is none other than the amino acids. So these two are the amino acids, 4-amino benzoic acid and as well as 2-amino butanoic acid. So in the case of butanoic acid, you will have it in this way. That's the structure. So carbon 1, 2, 3, 4, and you have your this. But what's the key characteristic about amino acids is that they're in natural fact ionic actually. They're ionic because the H from the carboxylic acid, alright, will be donated to the amine group, therefore allowing the amine to be NH3+. So bear in mind that amino acids are in fact ionic and they are crystalline in structure as well. So let's take a look at the other one, which is your 4-amino benzoic acid. So in this case, similarly in the same vein, the H+ has been lost from the carboxylic acid group and given to the amine group. So hence, in a nutshell, in amino acid, NH3+ is in fact your acid group, or is the functional group that's responsible for its acidic behavior, while on the other end, your CO- is responsible for the behavior of amino acids as a base. Later, we have a section that will cover amino acids specifically. So if you ask which of the compounds here form ionic compound, it will be both the amino acids that we talk about. Aside to that, there will also be the quaternary ammonium salt. So all these are highly soluble in water, crystalline in structure, and high melting point, high boiling point. The next, which are the compounds that's not able to form hydrogen bonding, we'll be going after 3rd degree amine, because in 3rd degree amine, they lack the electron deficient hydrogen. Similarly, we have a 3rd degree amine here, which also lacks the electron deficient or protonic hydrogen. And similarly for this as well, because there is also absence of electron deficient or protonic hydrogen. You may have elucidation question, which involves compounds that contains nitrogen. Typically, such questions are easy because there are only 4 functional groups you need to think about. I acronym them as NANA, which is nitro, amide, nitrile, and amine. We separate them this manner primarily because for the case of nitro and amide, nitro is NO2 and amide has a functional group CON. So therefore, in both these groups, the unknown compound will need nitrogen as well as oxygen atoms. Certainly in the case of this example that we're illustrating, there isn't any oxygen. Therefore, possibilities are nitrile or amine. Before we get on with that, it is also good to note that the only compound that actually comprises nitro group that you have learned is your nitrobenzene. And for CON, and for the case of amide, it is quite clear that it's neutral, and the reactions that they can undertake will typically be reduction or otherwise hydrolysis. And the hydrolysis of the amide will typically get a carboxylic acid and a base, and depending on whether it's acidic or alkaline medium, they could be ionic. So let's take a look at this compound and explore what possible structures could it be. So in this case, there's two options. One is obviously it could be a nitrile, but we know it cannot be, because if you put a nitrile, then in the compound they should only have five hydrogen. So by and large, you can conclude that any nitrile would actually have very few hydrogen atoms. So clearly in these questions, the answer is actually amine, because amine will need a CH2 and then followed by a NH2.